Like this disaster in Taiwan that ripped through the heart of a community.
The cables began to snap. It was like fireworks going off.
A state-of-the-art bridge destroyed in seconds.
This triggered a major rescue operation involving the Coast Guard and the military.
The tragedy revealed a hidden design flaw.
Hundreds of tons of steel and concrete came crashing down. The destruction was devastating.
The island of Taiwan, on the western edge of the Pacific Ocean, boasts Asia's top-performing economy and is one of the most technologically advanced places on Earth.
Taiwan is well known as the world's leader in computer chip technology, but it also has one of the world's largest fishing industries.
Nestling in the shadow of the central mountain range lies the port of Nanfangao, home to one of Taiwan's biggest fishing fleets. Chun Sen-chan is the executive secretary of the Fishermen Association.
是东部最大的渔港，也是全省3大渔港之一。我们本会的会员总共有16200多个会员。我们的渔船船只大概有800多艘的一个渔船的船只。
In 1996, construction began on this 140-meter harbour bridge to allow larger vessels in and out, as journalist Philippe Charlier explains.
The old bridge was too low, so only small boats could get in and out of the harbour. And the one that was built at Nanfangao Harbour was unique.
The new bridge would be the first bifurcated single-arch bridge in all of Asia, and only one of 2 in the world.
Bifurcated simply means split into 2 branches, much like a fork in the road. What made this bridge stand out is that the arch itself was split into 2, a bit like a wishbone, creating 2 legs on either end.
It was designed to be strong in terms of being able to withstand earthquakes and typhoons, but also to be aesthetically pleasing, because this is a very popular tourist area.
Professor Chung Che-chu from the National Taiwan University is an expert in bridge and earthquake engineering.
Nanfangao Bridge is a beautiful and a simple structure. A single span steel tight arch bridge, because we don't want to have the current in the water to block the fishing boat passing through the harbor. Therefore, we use the 2 bifurcated legs. This is very important, especially for resisting the earthquake load or the wind load.
To keep the harbour entrance clear, this unique bridge supported the deck from the single arch above with 13 steel cables or hangers, anchored to bucket-shaped steel troughs between the roadways.
The bridge deck is supported by the cable, which transfers the bridge weight and the traffic load into the arch.
Completed in 1998, for the next 20 years, traffic flowed smoothly both under and over it. On Monday, 30th of September 2019, Typhoon Mitag hit the coast of Taiwan, with winds of up to 140 kilometers an hour.
There was a typhoon that swept past the northeast coast, and it created considerable sway on the bridge.
But Mother Nature wasn't done yet.
In the early hours of the morning, there was an earthquake of 3.8 magnitude.
By dawn, life was returning to normal, but all that changed at 9:30 a.m. $320 tons of bridge and a tanker truck fell suddenly and without warning around 18 meters into the water below.
That one truck set off a chain reaction, causing the bridge to go down in seconds.
There were 3 fishing boats moored under the bridge with crew aboard.
There was no warning and no chance to escape. A massive rescue operation was launched, led by the Taiwanese military.
It involved the Coast Guard, the National Airborne Service Corps, and Navy and Army divers.
With members of his fishing community in trouble, Executive Secretary Chun Sen-Chan went to work.
第二个，我们呢成立了一个有推广课，成立一个前进指挥所，整个地方上的一个重要的位置的一个。再来就是清查断桥之后，桥下有3艘渔船。
More than 200 people spent 3 days searching the wreckage. Incredibly, the driver of the tanker truck was rescued, and although injured, survived the disaster, along with 12 others. But not everyone was so lucky. Tragically, 6 people on board the boats died.
全部把他找到，虽然不幸的罹难，但是我们也非常尊重他的大体，把他做了很大的一个处理。
An investigation was launched to find out why the bridge had failed so catastrophically. Taiwan's leaders wanted answers, and no stone would be left unturned.
2 days after the collapse, Premier Su Zhen-Chang ordered an investigation and ordered inspections of all the bridges in Taiwan, which number over 20,000, to prevent this happening again.
The first question, had the typhoon or earthquake caused the collapse? Not so, says Professor Chung Che-Chu, who was on the team.
No. The bridge was standing there for almost 20 years. Then the bridge failed, so that means there's a system-level damage. So probably due to the environment effect, not due to the single event effect.
The bridge had withstood years of typhoons and quakes. The next suspect was less dramatic, the harbor's salty environment.
Investigators wondered whether the collapse could have been caused by the very thing the bridge was designed to cross, the sea.
If we look at this damage part, it's damage due to corrosion of the tendon. So with salty environment, so tendon rupture may be the major issue.
Engineers discovered that water was leaking through the unique bridge into the steel pockets that anchored the tendons.
You can see the tendon needs to be anchored on the girder. So the engineer built a steel bucket in order to hold the tendon. But after many years, this steel bucket becomes a good place for the water to store up.
As salt water collected in the anchor points, the waterproof seals on the metal pockets gradually hardened and cracked, as did the tubes covering the steel cables. This allowed rainwater to leak into the anchoring mechanism, weakening the entire structure.
Further investigation revealed there were no drain holes.
The tendon is hanging there, and we don't see the drainage for the steel bucket. So that's become the worst design for this case.
The salty water was trapped and slowly corroded the steel tendons. As this investigation test shows, they simply didn't have the strength to hold on any longer.
Once the first cable gave way, the next, which was also badly corroded, failed, and so on in a domino effect along the bridge, which brought the whole structure down in seconds.
The investigation found other factors had contributed to the collapse, from construction techniques to routine maintenance regulations, which hadn't required examination of the anchor points inside the bridge deck. This meant the problem went undetected for nearly 20 years.
Inspections were carried out between 1998 and 2016. However, the anchor supports for the cable were concealed in the deck of a bridge. And unless you had special engineering training, you probably wouldn't know that you needed to look inside to check for corrosion.
After the collapse, all bridges with cable supports were checked, and from now on, bridges with a unique design, like the one at Nanfangao, will only be inspected by specially trained engineers.
The bridge in Nanfangao was crucial to the community, And just over a year after the collapse, construction began on its replacement.
The groundbreaking ceremony for the new bridge occurred on October 5, 2020, and it's due to be completed in August of 2022.
When finished, the new bridge will be a more conventional concrete structure with no arch.
This incident should have been prevented. We just need to remember this lesson and really do the examination to make sure the problem of the tendon corrosion can be prevented.
Hopefully, once again, Taiwan will be blazing a trail with cutting-edge and eye-catching engineering.